However, every now and then, we get to experience a historic event ourselves. Next Monday, August 21st, is one of those times. That morning, we'll be experiencing a partial solar eclipse right here in the Wenatchee Valley. In Project 2, Resources for Informing, from the Advanced Communication Series manual, Speaking to Inform, Lloyd Smith will discuss what is going to happen that morning and offer some suggestions for viewing it safely. Here's Lloyd Smith and 92%.
Thank you, Derek. It really is a historical event. I don't know how many of you were around the Wenatchee Valley on February 18th of 1979, but that was the last partial solar eclipse that was visible here. The next one won't be visible for about 120 years. So I recommend you make something of the one that's coming up on Monday. It really is an unusual thing, but it's also a very commonplace thing. What I'd like to do tonight is to talk a little bit about what an eclipse is, a little kind of an 8th grade science review, and then talk about how to view it safely, because that's a critical thing. You can do yourself some real harm if you get a little bit enthusiastic next Monday. So first of all, what's an eclipse? A diagram. This is one of those things, a little bit of science. You're not going to look thoughtful and nod the way you did in all of your college classes. It'll fool you into thinking that I'm back in the classroom. An eclipse is a simple thing. The sun, the earth, and the moon all have to line up perfectly. What it amounts to is that the sun casts a shadow of the moon on the earth. Now, you might be wondering, why is it that we don't have a solar eclipse every single month? Because, shouldn't it line up? Well, as it happens, the moon is inclined about 5 degrees to the Earth's equator. In other words, it's not on the same, it doesn't go around the Earth on the same level as the equator. So it creates a kind of a wobbling effect. Also, the Earth is inclined about 3 degrees to the sun's equator. And so only every now and then does the shadow of the moon hit the Earth. Frequently it misses, and that's why we don't see it, because we're not in outer space. Right? Keep that in mind. Now, when the shadow shines on the Earth, it forms a narrow cone. That cone is about 50 miles wide on the surface of the Earth, and so the path that shadow takes is what creates the total solar eclipse. In the case of Monday, what we're going to see is that that shadow will touch the United States on the Oregon coast. It'll take a diagonal line across the nation and leave on the South Carolina coast. Now, we are not in the path of that cone, but that's okay, because about 200 miles on either side of the cone is when people see a partial solar eclipse, and that's what we're going to see this coming Monday. It's really important to know a little bit about how these things work. There's a lot of popular material. For example, this month's Discover magazine focuses on the eclipse. There's an article in Scientific American, but I don't recommend that unless you're, a scientist. And this is more for regular humans, I guess. They can get a little bit technical at times. There's an outstanding website, though, that I recommend most highly, and that's the NASA website, nasa.gov. That has everything about the space program on it, but most importantly, it has a big section on the eclipse, a link to get to a lot of stuff about the eclipse. When you look at that, you will find that they devote an awful lot of attention to viewing it safely. Now, the sun, you want to picture a gigantic thermonuclear furnace in the sky. It's giving off an incredible amount of radiation, and this is not the kind of thing to mess with. You can easily blind yourself by looking at the sun. People have actually blinded themselves looking at the sun. Now, we're going to get a 92% solar eclipse. It'll look at the height of it about like this. You'll see a little thin sliver of light from the sun, and it seems like 92% should be close to 100, right? So it can't be that bad. But that 8% can really do you some harm. There are two good ways to look at the eclipse. One of them is with these stylish glasses. You've probably seen these in stores. I picked these up for $1.99 at Fred Meyer this morning. There are lots of others too. The main thing about these is that they're safe. This morning I was looking online and there are some amazingly stupid stuff about how to make yourself safe during the eclipse. One guy explained that if you look through a beer bottle, in the brown glass of a beer bottle, that would make you safe. No, it will not. Another guy claimed 3 or more pairs of sunglasses, like lined up, stacked up. No, it will not. Another guy claimed if you look through the silvery part of like a music CD or a DVD, that will do it. No, it will not. Nothing will do it. You have to have something that meets a standard called ISO 12312-2, which is an international standard for the darkness of these glasses. Essentially, nothing gets through it. You can actually put these on and look at the sun and see the sun. It's the only safe way to do it. Now, here's the thing, though. If you have kids, it would be a real shame, or grandkids around, it would be a shame for them not to experience this eclipse because it's not going to happen again. But you do not want to risk a kid pulling these things off while he's looking up at the sun. And so the safest way to look at it is with what's called a pinhole camera. I made one this afternoon. Take a hunk of cardboard. This one comes from a shoebox. Cut a hole in it about 1 inch or 2 square. You tape a piece of aluminum foil over the hole, and you can't see this, but you poke a hole in it with a straight pin. The way you use this thing and what makes it safe is that you sit or stand with your back to the sun. You take your official pinhole camera, you take a piece of white paper, tape it to a wall or set it on a chair or whatever, and then focus the little circle of the sunlight that you'll see on the piece of paper. What you'll see is the moon slowly eat the sun and then it'll go off of it. But this is really the only safe way to do it if you've got kids, because nobody's going to be looking at the sun. You can adjust this. If you bring it back, the sun will get bigger but a little bit fuzzier. If you bring it down, it'll get sharper and a little bit smaller. But I recommend this if you've got young people, because you don't want to mess with it. The one thing, by the way, you do not want to do is to go anywhere where there's a telescope unless a pretty skilled amateur astronomer who knows what he's doing and has the right equipment has set it up. You absolutely want to make sure your binoculars are left in the house. You can instantaneously and permanently blind yourself by looking at even an 8% sun with a pair of binoculars. You won't even know it's happening until it doesn't get light after the eclipse, and you probably won't like it. It's a big deal. It's going to probably, for most of us, a once-in-a-lifetime thing to see this coming Monday. It would be a shame not to see it, but you've got to do it safely. Mr. Postmaster.